Good morning, everybody. I hope everybody can hear me now. Thank you all for getting up this early. This talk, this is going to be me, Oliver. I'm part of the linux-sunxi community. There's various people that don't know how to pronounce it, so this is my way. Everybody has a different interpretation, I guess. It's going to be a pretty busy schedule. I want to tell you a lot. I'm very anxious to tell you a lot, and I hope it's very interesting, but we're a little pressed for time. It looks more than it really is, but the first thing I'm going to tell you is this, what sunxi now really is. First of all, no. It's not sushi. It sounds like sushi, I guess, if you pronounce it that way, but it really is not. Could it be related to the sun or the Greek letter C? Maybe. Could it be related to Sun Tzu? Possibly. To be fair, we don't really know. What we do know, of course, is that it's a system on a chip. Who knows or has not heard of what a system on a chip is? At least one hand. A system on a chip basically is your regular CPU. It could be an x86 or an ARM processor or MIPS. And they add a bunch of features like a USB controller, a serial ATA controller, all sorts of buses, all into one chip to make it very easy to create a board or a tablet or a PC with little components and everything nicely integrated. We know that the chip we're going to be talking about are called the Sun4i. We don't know what the first chip actually was called, the first series. It's probably Sun something, maybe just Sun. We don't know. It's too old. Nobody really had heard of it or had it. We know from historical research that the real old first discovered chips was called the Sun II or Sun 2, I guess. And from there on, we know there's a Sun 3. And obviously, the geeks that we are, Sun XI, or replace the numeral for a variable, is where this comes from. Now that you know what a sunxi is, or what an ARM store case, I'll tell you a bit about myself. I've been a Linux enthusiast for 15 years, maybe a little bit more. I've administrated several servers, desktops, I guess, too. And I've been a user for pretty much almost the same length. I've been a user and developer of sunxi for, I guess, a little bit, a year and a half, maybe a little bit more. Could be almost 2 years now. And I started actually as a regular user, working a little bit on the wiki page that we have that I'll mention briefly later on. And then I slowly enrolled in, submitting patches, working on features, things like that. I'm also, just let you know a little bit of me, the official digital television scan files maintainer. If you ever heard of DVB-T or DVB-C or DVB-S, which is satellite reception or terrestrial reception, those files are stored somewhere on the internet. I maintain those. And I have been a small-time, very small-time, kernel contributor. I've sent a few patches that have been accepted, unrelated to sunxi and even including sunxi already. And I was asked by Pack Publishing to write a book about these SoCs, beginner style, for people that are just starting into working with SoCs or this one specifically. It should be, if I manage to keep my timelines, released in July. Let me just grab it. The sunxi SoCs are made by a company called Allwinner, and it's only fair to at least mention them and give you a short, brief history of what they have done. Allwinner Technology is a Chinese company. They do not have their own factories. They, as you saw in the first slide of what is an SoC, they just puzzled together. They buy several cores, combine them. They say they even develop some of these cores and combine them, and produce these chips. I'm not going to read up all that. It's just some infographics that is from them, just so you get an idea of what they are and what they do. One of the reasons why this SoC is so popular today is that when they started in 2001, they got some government grants and were able to offer these chips for very, very cheap. I think if you buy them in huge bulks, you could get them for $7 a piece, which was at that time amazing, and even caused a small revolution in China, as all these tablet manufacturers that want to have the cheapest parts, don't care really about what it is, they just want the cheapest parts. They started to drop orders from RK or MediaTek and just swapped all over to Allwinner because it was so cheap. That made it that there were a lot of chips from Allwinner in a lot of tablets, a lot of set-top boxes, and so the community from there grew. They claim, and this is verbatim from them, that in 2003 they had 15% of the SoC market share, just below Apple, which is, to be fair, pretty amazing. They initially did power management units. That's where they started. When they probably split off or started their company, they did power management units. The same units that are in the tablets that these chips are in. And interesting, these two chips, which were the AXP152 and 209, were one of the first and, I guess, one of the later chips that are still used today. As I mentioned before, there is the really old Sun2i, Sun3i, and even whatever was before that. They call them, Allwinner calls them the F series. That's where they really kind of started with their first SoCs. The Allwinner A10, which was released in 2011, is what I just previously mentioned, the most popular and most used SoC out there. It's a simple single-core CPU, but because it's all over the world, so massively used, that's why we're here today. They later released the A13 and the NTS. Don't ask me, the sense in the naming of their chips. They're just cheaper variants of the A10. They removed some features or disabled, or maybe they were just bin parts, and just resold them as cheaper devices, even cheaper than the $7 that we mentioned earlier. And then just recently they announced it's already widely in use, it's their A20 dual core, slightly slower, I guess, if you compare single processing or single core processing. But because it's theirs too, it's more useful, I think. This slide is very interesting. It's verbatim from their marketing strategy. It lists their strengths. The top and the left one are, it's more marketing. It's not really interesting. But the third one, the open source support, is where it becomes interesting to all of us, because since we are all really interested in the open sourceness of everything. One interesting fact I really want to mention here, though, is that also, again, from their marketing slides, is they portray the GPL version 3 for their whole SDK or whatever. They really want to push open source. They really think they're open source. Yet we already know that they're violating the GPL themselves, even though claiming this on several occasions. They do try to improve, and we do have one member in the community that does try to enforce it with them. It's Luke Layton, I think. He has his own company. He works with chips like that, and he does try to push them to release with varying success to release the sources that are missing. I'll briefly touch now on our community, because that's also really a big part of this talk and of this chip, I guess, to us. As I said, this is our logo. We're the SoCs community. We have been around for a while, but before, we actually were we work with the Rhombus Tech company. They started to work or develop a little development platform where You could swap out your processor card, change it into a tablet, change it into a set-top box, change it into whatever you wanted, which is an interesting project. I guess most of the early people started to get interested in that project that way. Problem was, though, they used the A10 SoC because it was so open source friendly, but they could switch to another SoC anytime. They also were more interested in the hardware aspect of it and the whole system. And some of us were actually just interested, or mostly interested, in the kernel that comes with it. So we kind of split up from the, I guess they call it the ARM network community, or I'm not even actually sure. So we split up using their mailing list, their IRC channel, their resources, so that we could nicely separate everything, and it made sense. We have been growing very steadily over the last, I think, year and a quarter that we split up from them. We started with just a handful of people, I suppose. And right now, we have about 600 mailing list users. Most of them, of course, are lurkers, but still. 600 registers mailing list users. About an average, 130 people are either idling or speaking in the IRC channel, which is, pretty nice. Unfortunately, only about 20 active developers. That's really a rough estimate, if it's 30. All right, I'm sorry for those 10 people I missed. We would love to see more developers, but we're doing really good, though. These are the places where you can find us. We have our own website, our own wiki, where everybody can create an account and start editing the wiki. We have our own IRC channel. And we have our own mailing list, or soon-to-be mailing list there. It does accept mails. Right now, we're just still using Google Groups. There's some people who object to that. Now that you know a little bit about what Allwinner does, what we do, or I'm going to tell you what we really do. Linux-sunxi is not really just about Linux. It's one of the main people's interests, I suppose, what most people use. But we also do work on the bootloader, which I'll briefly go over now. There's actually quite a few bootloaders for the SoC in question here. There is U-boot, which was, we call it the lychee branch of U-boot, I suppose. It's what Allwinner actually released, but it does depend on we call them boot 0, boot 1. It used to be proprietary. It's one of those things Luke mentioned to get the source code from, as we found it was infringing on the GPL. So technically, it's open source now. I don't think anybody ever managed or even tried to build it. It sits on every Allwinner device with a NAND flash ROM. It sits on there on a partition, and it's responsible for bringing up the tablet, initializing the memory, and then it switches over to what we call their U-boot. We have made some small improvements to it, but nothing major. Our own U-boot, actually, though, we call it the sunxi U-boot, obviously, just a different branch, is compared to the mainline. We have not merged it all upstream yet. It needs a lot of cleaning up, but it is very fully functional. It does only boot MMC. You can only boot from the SD card, which can be a problem, but most developers actually do use that way, since you can easily swap out memory cards, so it's very nice. The memory initialization, which is the most important task of the bootloader for us, since the kernel can't do that, is actually done in this U-boot, which is why it's so interesting to us. It was donated, I guess you could say, from one of the former Allwinner employees who worked with Allwinner on this. And it's based, I know from experience that it's based on boot 0, actually. Then there is someone crazy enough to have tried to, or started to port it to bare boot. I don't know what bare boot is other than it's a U-boot 2 fork, or U-boot fork. They call it U-boot 2. I guess it's just one of those forks. They forked, I think, before the sunxi stuff got in it and added it later. And then somebody is crazy enough to actually port it to core boot. And And that person was getting along quite well. He actually fixed some bugs in RU-boot. He did find out, though, that it wasn't as easy as he initially thought. There are some things that Corba doesn't really even consider yet, or hasn't found a straight way to do, like booting from MMC, for example. I haven't followed it perfectly to the letter, but. Now that we've talked about the bootloader, one of the next things, of course, is when you bring up one of these chips is the operating system, naturally. Obviously, it shouldn't be a surprise to anybody, Linux. It runs well. It's well supported. And we know that there's patches for FreeBSD going. And from what I know, it also boots and it works. If anybody saw the Titzen, I don't know, at home talk yesterday, they actually mentioned they did it or doing it with Allwinner CPUs. And then there's Firefox OS. If you haven't heard the news, Firefox is, or Mozilla is announcing their own tablet based on the A31, I think. But more on that later. I'll burn them for that a little bit later. And it's not supported yet, but somebody showed interest or wanted to get help to port Minix to it. Now, all these operating systems, or Linux really for us, doesn't mean that much. It's just a kernel. But you really need a distro to support that kernel. And we have quite a few, actually. I do want to, I'm not going to mention everything, why it's important or why it's interesting. I do want you to know that the first one, Fedora, is being ported by one of the Red Hat employees in his spare time. He works with the community. And I think it is the best supported image or rootfs that we have right now. It works, as long as the device is supported, it works smoothest. You just pop it on your SD card, you run the setup from a shell, and it just works. The other ones are either created by fans, I suppose, users. They may, they hack a little bit their own rootfs together, where it's possible, they hacked it together and they offer this image for use. Or the Linara one, it's just a generic rootfs that just works. They all still are just images. Somebody puts all the right components together, and there you go, image. At least I tried with Debian. You can actually just bootstrap it. So you actually manage to boot Fedora, Hans's image, and from there on bootstrap the entire system as the installer normally would to one of these boards. And I do mention specifically not Android, because we don't have a real community supported Android version, which is strange, you would think. There are Replicant, Replicant is a big work in progress. I think Paul, who is maybe around here, oh, there he is. He said that he's going to start to work on it. He said that for at least 3 months now, I think. Which is very cool to have, of course, and why I'll mention briefly later. But it should be quite possible to actually port Replicant to it. And there are, and that's why I said no community support. There are tarballs with CyanogenMod mod for it. A user built it, offers it the whole thing for download. Somebody did it. We don't know that person. It doesn't interact with the community, and that's okay. But that's why I said it's not community supported. We don't know what updates are coming or nothing, or if it even still works today. And then there is the Allwinner SDK Android version. It's loaded with GPL violations, we know, because I know they use certain parts that they don't give us. Most of them is the touchscreen controller in tablets, which is weird, really. It's a very simple microcontroller on an I2 bus, I2C bus. And it shouldn't be that special, but they just get blobs from manufacturers, and God knows what happens then. And of course, they ship only their violating bootloader, which I said earlier, we do have the source of for boot 0, boot 1, but only for, I think, one specific chip, 820, I believe it might be. I'm seeing question marks there as well for my friends. So while we do have it, and we don't really need it badly because we have our own U-boot support quite well, it's still shipped that way, and officially it's still a GPL violation. I earlier mentioned you have your Linux operating system, I guess. I don't know what really it goes under. I do want to start talking about the kernels that we support or are supported. As I mentioned earlier, the lychee branch of kernel, or that's how it comes, there's 3 versions right now. Mostly found still today, I guess, is the 3.0 stuff. That's what they initially brought their SDK out under. That's what most kernels are, or tablets are shipped with. I think somebody's messing with the volume of the. All right, the 3.0 is what they're mostly shipped with, and so that's what we see a lot. And it's important because, as I said earlier, these touchscreen blobs, these touchscreen drivers, are still depending on 3.0 specifically. 3.3 was their first next major version that they started to ship with the SDKs. And we also see a lot of users, I guess, that build their own kernels based on the SDK asking questions about the 3.3. And I guess it's slowly replacing 3.0. But as you all know, OEMs, manufacturers, users, don't really upgrade their software, their kernels, their tablets. And we recently got a very interesting release, I think 2 months ago, 6 weeks ago. We've got their 3.4 version, which is having patches actually from the community. It's the first time that we actually seen stuff being used by them. They actually, the 3.0 to 3.3 step they did, they ignored everything we did. They just kept on doing their own thing in their own horrible way, really horrible way. And so it's really interesting to see at least the notice, and they did pull back something from 3.8 to our kernels. Then we have the sunxi kernels. As I mentioned before, we split off or used the code dump that we got from 3.0. And we started to use that. We actually have 2 branches. The staging branch, where all the development goes on, which is then ported to a stable branch. 3.0 is where we start forking. We start to make improvements. I think we actually did the 3.4 switch upgrade ourselves. I think we did, didn't we? Yeah, we did. This was before my time. And 3.4 is where all the work gets done right now. We actually have an experiment, and maybe the order of the last 2 items should be reversed, but they make a little bit more sense that way. We've started to have a 3.10 experimental tree where we have mainline patches, and we'll integrate, and I'll mention that a little bit later, some of the 3.4 work. 3.0, as I said before, is actually depreciated by us. We don't really care for it. It's really old, and we're doing all the work on 3.4, and it's really hard. It's a really tough sell to ask people to port their patches back to 3.0 when we don't even know really people using it. But as I said earlier, we still need it, hopefully not for long, or to some extent for certain use cases. 3.4 right now is mostly in maintenance stage. We'll accept patches, we'll do some minor improvements, but we try to keep it as steady as it is. We do backport patches from whatever Allwinner releases from in their SDKs. If there's fixes or new touchscreen drivers with source, we'll do backport those. And we keep it in sync with the long-term service release of 3.4, so the official upstream 3.4. We have done and will do, there's still lots and lots and lots of bug fixes in it. Because, as I said earlier, it's a horrible mess. These people, I guess, code for money, not for passion, like I hope most of us. And the quality isn't really important as long as they can release it as quickly as possible. We try to limit the number of cleanups in the code to the bare minimum so that we can easily, more easily, can do the backports. If you clean up a whole section, make it all pretty and perfect and awesome, and then you get a new version from Allwinner, which is basically the same stuff again. It's starting to get harder and harder to add your own fixes, which you try to avoid. So keeping the cleanups to a minimum, backporting is easier. I want to talk a little bit more about the 3.10 experimental tree that we recently restarted. It's interesting because 3.10, like 3.4, is a long-term release. Long-term service release. Long-term release. Long-term support, sorry. Which means that upstream patches, security fixes, and all that will be coming down longer. And there are rumors, or I don't think it's a hard fact yet, but Android 5 or one of the next big Android versions is likely, very likely, to depend on 3.10 because it's a long-term service support. Also interesting to us is because our mainline support started around 3.8, we have in 3.10 we have the most basic, the early long-term, the early support. We can bring up a chip using the mainline. You can actually download mainline now and bring up a chip. Later patches that, as we're developing like crazy maniacs, later patches are actually backported or we're trying to backport to 3.10. So in the long term, 3.10 can actually replace 3.4. And 3.10 is really interesting because of new features. KVM, the kernel virtual machines, like the Zen, the hypervisor thing, wasn't available for ARM in 3.4. CMA, it's just an example. A continuous memory allocator, we actually did backport it to 3.4 because we really needed it. And so there's more small features that are really interesting that are in 3.10 that would cause a lot of work to get in 3.4. The mainline kernel, as I just mentioned, we have actual, in 3 so much, we have actual a way to bring up the kernel from vanilla Linux. It's all done by the community. Allwinner has not helped us, well, I suppose they answered questions if we really asked them, but they've not really brought any patches in or helped or start to support anything. It's all community work. It's an upstream. It's right there. We do have our own copy. We do have our own branch for it. It's the sunxi development branch. This is where all the new work is going on, stuff that hasn't been merged yet, or stuff that might be revised or can't go up yet. But it's just a collection of patches so that you can use mainline with the most features available to you, if you're willing to take the risk that it's all experimental. And also we have sunxi next. And the reason why I mentioned these two is because, of course, there's a lot of people always coming in and saying, oh, which branch should I pick, which versions do you have? sunxi next is patches that are accepted and will go into the mainline whenever the window's open and whenever it is released. So that's as close as you can get without having to patch your own things. I was not supposed to have this one all slow, or all in separate parts. The mainline kernel right now supports pretty much, or these are the most basic features that it has support for a little while. It's also one of the most important things to have support for. It's important to be able to bring up your board. Interesting enough, I should mention the watchdog really briefly, really shortly. The watchdog is interesting because it's actually the only way to reset your chip. These SoCs, they don't have a special function to power them off. You can't reset them. The watchdog is actually the only bit that's responsible for doing it. And Ethernet is interesting because it is possible to actually run a headless server with these SoCs from mainline using a root FS on a network-mounted file system. Since it's such a fast-changing subject, the best way to find out, is my feature supported? Is there somebody working on it? Is there something I can start working on? That's the link where you can find the most up-to-date information. Right. I wanted to skip this next chapter, but I do want to very shortly, briefly touch on it because it's quite important to users of these kernels. The FEX file, or the FEX system, I don't think you even know what it stands for, is a ini file, configuration file. It's a key value pair matching thing, if you want to get a little bit technical. It's actually in binary form, so you need a very, very, very simple compiler that we support or wrote. And the thing why it's important is because all the 3.4 and all the Allwinner stuff is built entirely around it. Each of the drivers they have, or they support, I guess is the right word, parses this file in memory and configures itself. Like it checks the file, like the driver for the SPI bus, for example. It checks its own section, finds its own section. Am I enabled or not? If it's enabled, it continues. Which port should I listen to? Which pins should I configure myself to? And why it's important to know is a lot of people come in and think it's like a magical thing. It's like this binary file that gets uploaded into the SoC and it magically configures the chip. But no, every driver is simply hacked around it. So I see some of you probably thinking, but device tree, isn't that what it's all supposed to do? Isn't that what device tree is for? Yeah, but it's probably older, at least for ARM. And even if not, it actually comes from from Allwinner's work before their Linux support. They had this thing called Melis, or I don't know, which was a very basic media player software. That's where they started to use it. But it's still very important, not because it's such a great system, but because a lot of the OEMs that manufacture these tablets, they learned a little trick. They know they got this a standard template from Allwinner. They modify it horribly most of the time. They don't really know what they're doing. They just know that they try a few things, or God knows. And that's the way they set up their tablets. So by by possibly removing that and switching entirely to the device tree, you lose all these users and all these OEMs from even remotely considering using our stuff. But as all good things, it's replaced in mainline by the device tree. The new mainline stuff does work properly with the device tree. And our intentions anyway, and the early work has started, to make both the device tree and the FEX file script parser thing a happy couple in 3.10. This way, we can keep the mainline stuff clean, have it all backported, have all the drivers there, and still easily forward port the 3.4 stuff. That's really important to have there, that either nobody has started to work on yet, or it's going to be a huge pain in the butt to actually get support of mainline. Now, all this is interesting and fun. It's all software. I'm sure there's always people interested in hardware, because what's the fun of software if you don't have hardware to use it with? There are quite a lot of development platforms. There's even open source hardware platforms. And unfortunately, I didn't get one to show, but this is the Allwinner line. And it's very interesting to mention is that Allwinner has a lot of hardware platforms that are open source. And this one is also open source hardware. You can download the schematics, the bill of materials, everything you need to reproduce it. And while most of us can't, it's still very, very resourceful and helpful to have and possibly improve on. Finding bugs, for example. I also find the name interesting or funny. It's called the Lime, which is a pun on the Raspberry Pi, I guess, a little bit. It's about the same price for a faster processor. No dependency on a binary blob like the Raspberry Pi. And it's, I think, a little bit smaller than Raspberry Pi. And small size comparison, because I knew I wouldn't get one to show you guys. It's really small. Oh, there we go. Thank you. This is it. It's really small. It's closed board. If you have not been to the Linux booth yet, you can look one on the inside. It's only fair, of course, to mention the other ones. The QB board. This is QB board 1. There's actually a QB board 2, which is exactly the same, just a chip swap, because they're pin compatible. It's only fair to mention these is, as Linux also sent a few of these to developers. It is open schematic. They have released their schematics, but it's not fully open source. So if you have to choose between the two of them, pick the Linux stuff. And this is the ioma, I guess it's called, board. It's a swappable. I mentioned it very, very early on. The left bit, it's a PCMCIA form factor. It's like those old PCI Express for laptops. So that's the form factor they used. They wanted to make a board so that you can put in your laptop, put in your set-top box. And the Improv board, which is fully open source hardware, is the first board that allows you to plug in the board and use it, I guess, like one of the Linux boards or the Raspberry Pi board, the QE boards. It's the Improv board is open source hardware. The ioma, interesting, is not yet. The creators say that they will release everything, make it fully open source hardware, once they earn back their initial investment, which is, I guess, fair. But besides these open source platforms, developer boards, which is most interesting to us as developers, there's also a huge number of tablets being sold with these chips, HDMI sticks, and set-top boxes. HDMI sticks are on the left top. They look like USB sticks, but you plug them into an HDMI port, you supply them with a little bit of power, and you basically have an entire board to play with, limitedly. Allwinner chips are extremely easy to hack on, or they're safe to hack on, I think is better word, because they're almost unbreakable, or really they're unbreakable. It will always boot from the memory card first, which means that if you, 10? Which means that if you swap out your memory card that's, totally bricked the device, or, the operating system is totally bricked, you swap out the card, you make a new one, it boots again. If you boot from the flash memory, and you corrupt that, that's okay. You pop in an SD card, and you can still salvage it. And while for users, that's not really extremely helpful, for developers, it usually means you can just fix whatever you want. I think Luc, who's not here right now, bought a broken tablet from eBay. And the user said it's completely broken, you couldn't fix it, popped in an SD card, and it ran again. If all else fails, Allwinner has added a safety feature called FEL, or FEL. I don't really know what it stands for. It's a safety mechanism. It's built into the chip itself. And it allows you to inject code over USB. It's a special mode. You put the chip in, you connect to your computer over USB, and you can upload binaries. And even that way, recover stuff in case you don't have an accessible MMC. And I see I have to hurry up a little bit. I thought first of going into details what every chip can do and how cool it is and what it can do. And the wiki is really a much better place to learn, does this chip support my feature, or can I do this or that with it? These are the 4 main chips that we support. We have open source drivers for nearly everything. And in theory, it should be FSF endorsable. Nobody has contacted each other yet, probably, and it depends on what you want to do with it. So everything you would expect is happy, joy, sunshine, great. Please. And there we stop. Oh, there we go. But But not everything is that. Actually, I took huge images, like 4K resolution, whatever I found on the internet, and scaled them down and figured out it'll handle it. It does. It goes. But there's a storm brewing. And the storm is the A31S, or A31, and the A80, which both use PowerVR, which doesn't really have a reverse engineering community around it. Nobody really cares for it. It's just shit GPU. But ask Luke about it later about it. Which is why it's surprising that Firefox or Mozilla chose that specific chip for their operating system. Sure, it's a little bit fast. It's a quad-core, blah, blah. It won't really get supported really well, at least not by us. None of the developers have it. None of them are really that interested. I think there's 2 people that have a board with it. And then there's the new A23. And I made a slide specifically about that is because we finally found one in the wild. Somebody ordered a tablet online hoping to be an A13. It was actually an upgrade to A23. We have the SDK for it, so we can get the kernel running everything, but we don't have a bootloader, which is important because the bootloader does the memory initialization, and without that, we can't really boot it, which is, you can work around it for now, but it's still annoying. But it does use the Mali, which is where Luke comes in with his Lima work. And then, of course, it's very important to mention these ugly things. And it's not by chance that a blob is ugly, but, is the closed source blobs, the closed source proprietary files. Mali is one of these blobs. It's the GPU in these boards. It does the 3D work. And before you start saying, but what? I saw this video last year where Quake 3 was running on the reverse engineered work. That's true. These 3 talks go specifically all about that, with the small exception being the last one. It's not really about the 3D thing, but I still wanted to mention it as Luke is very hard working on that. It all happens in the graphics dev room later this afternoon. Also, we don't have any driver for the GPS. But we do have the debugging symbols. If anybody wants to start hacking on that and starts to pick that up and find actually hardware, because we just know there's 2 pins for GPS. We don't know what to connect to it. It's possible. Not the touchscreens. I mentioned the touchscreen blobs a few times already. The chip has its own internal touchscreen, and that one is actually supported in mainline already. And then there's the boot ROM, which is a little tiny little bit of code embedded into the chip that's responsible for actually, checking the memory control or the multimedia controller, checking the NAND flash, check if everything is, coming up. But we have started to, well, I guess you can't say reverse it since it's read only. You can't ever write it, but we start to document it. And then there's the setter X, which the X stands for AV, audio and video, which is responsible for audio decoding and video decoding, which just makes these chips really interesting. And then we quickly move over to demonstration. Oh boy. There it is. This is done by 100% open source drivers software. There's no binary blobs. There's no firmware uploaded anywhere. This is all open source stuff. And it's amazing that this works. But let's see if I can show. I think it's this one. The binary driver, actually, the binary blob, has problems with this one, where we can actually play it back, and the binary one cannot. So you can already see slowly things improving. And I suppose the most interesting bit is that this entire presentation was run on one of these by a USB port. So you can see it actually functions as a regular desktop. I mean, it's not super fast, but for a lot of people, that's not important. If you just want, your grandmother just wants to browse some emails, surf some websites, sure. Since I'm running out of time, If you want to contribute, if you want to help, the wiki always needs help. If you have a device that's not supported yet, we have an excellent new device how-to. If you follow that and contribute your fixes or changes, your device will automatically come up, and you're helping us. And we need help porting to these OSs for these specific chips. And of course, kernel patches. And I'm sorry for rushing through the last bit really fast, but we ran out of time, I think, a minute ago. Oh, we're fine. Is there time for questions? Sorry? Is there time for questions? Yes. Oh, yes, there's time for questions. Does anybody have a question? I think we need someone with a microphone. Just one question? Wow. Either I sucked really bad or it was very clear.
Do you think that for the Lima blobs we will be stick with closed blobs, or is there some hope that reversing engineering efforts could bring completely open?
Okay, if I understand your question correctly, is it possible that these devices will be able to run fully open source 3D? Yeah, we saw last year with the Limara work done by Luke that he's figured out the entire 3D GPU. Luke does actually his most, or not most, but a lot of his work on one of these Allwinner chips, and he will showcase where he is at right now this afternoon.
In the graphics room?
Graphics dev room, yeah.
I have another question regarding the boot ROM, first stage of the boot chain. Have you encountered seen platforms with sunxi Allwinner chips which implement secure boot?
I was going to talk about the security of these chips and secure boot and all that. I decided not to. I found it to be a little technical for the first introduction, I guess, to these chips, maybe next year. Very briefly, the chips do have support, I guess, for crypto hashes and all that inside the chip. And they marketed their chips that they should be able to do it. But there's just quite a lot of security features. One of the things that I mentioned earlier is that it always boots from MMC card first. It's great for users and ways to unbrick it. It's horrible for security because you just pop in your SD card, you boot, and you can use the file system.
So in the commercial boards, you think that it is not enforced? You can boot the image?
It really, if I understood it correctly, if in the future it would be possible to use secure boot with these devices, it depends on the board manufacturer or how the board is set up. You would have to disable certain features so that they can never be used. For example, you could not use the USB on-the-go port, which is used by the FEL mode. You would have to not map out the MMC pins and always force that way to boot from NAND and nothing else. And then, in theory, you could get quite far. But I don't see this happening because nobody has done it yet. We don't even know if the hardware actually does what it says it should do. There's some bits in it that enforce certain crypto things at boot. We don't even know if they work. So it might be likely. I know that at least for A31, I think there was some rumors that Windows 8 was going to, or RT was going to maybe support it, but we haven't seen anything forming in that way yet.
All right, the time is up. Thank you very much.
Sure. Thank you.